This is day 5 of Unit 5. We're going to take some notes on inequalities. We're going to get going and use some of the information we've previously used to help us get through this stuff. All right, so the key thing here is that we want to find solutions. To find the solutions, we need to find ordered pairs, x and y, that make the inequality true. So here's what we're going to do. We're going to substitute the xy values into the inequality, x for x, y for y. If we get a true statement, then we have a solution. So in this one, we're looking at the inequality, x minus 3y is less than 6. Now, some of you may be saying, well, what are inequalities? Inequalities, any math statement that has a greater than, equal to, less than, or less than or equal to. These are called inequalities. If you notice our equal sign is not there, we have a less than sign, so we call this an inequality. So I've taken the liberty of writing this inequality in preparation for testing each of these 4 points. Remember, the first number is the x, second number is y in the ordered pair. So I've got a 0 minus 3 times y, which is also 0. And the question is all the stuff on the left less than 6? Well, this is 0 minus 0, which is 0. And you can use your calculator on this part right here if you struggle with arithmetic. Just type that in and then write down your number. You're going to see that it's a 0. So once you get a number and a number with your inequality, you ask yourself, is it true? Is 0 less than 6? Yes, this is true. $0 is less than $6. So what is this guy called? It's called a solution to the inequality. And we repeat. New ordered pair, same inequality. I've got 6 minus 3 times a negative 1 is less than 6. That's what I'm testing. So if I type this in my calculator, I'll see that I'm actually adding 6 plus 3, and that's going to be a 9. Is $9 less than $6? No, that's false. So what about this guy? This guy is not a solution. Pretty simple. You either are or you aren't. It's either true or not. So as I come over here, I got 10 for x, 3 times y, which is a 2. And that's going to be 10 minus 6, doing my PEMDAS. And is that true or false? That is true. 4 is less than 6. Because it's true, we call this, what do we call this? That's right, we call this a solution. Go ahead and try D. Well, here's how you do D. You have a negative 1 for an x minus 3 times the positive 2 for a y. All right, so that's going to be 3 times 2 is 6. So what is negative 1 minus 6? It's negative 7. What do we know about all negatives compared to positives? All negatives are less than positives. So this one is true. That makes this a solution. So that's how you check it when you don't have a graph and they just give you the inequality in a point. Okay? So now let's fill in some of these blanks and talk about graphing. All right, the line in an inequality is called a boundary line. It's still a line, okay? Remember, you still may have to solve for y. Oh my goodness. And remember, if you divide by a negative, you will need to do what with the inequality symbol? You remember? We need to flip it. Okay? So this is kind of like a combination of things we've already talked about. So it's kind of like putting stuff in a blender for a smoothie. You put a little bit of this, a little bit of that, and you just blend it all up. Okay? So if we see anything that has a equal to or a line underneath this one is we're going to use a solid line. So treat this kind of like an equal sign, less than or equal. Just make a solid line. We're going to use a dashed line if you just see greater than or less than. So we're going to pick a test point, kind of like what they did up here. They're going to pick a point that's not on the line, and you test this point in the inequality sentence. If your result is true, like it was up here, you have a solution. If it is false, you don't. So if your result is true, you're going to shade that side of the boundary line. You're going to be shading half of your grid. It's called a half plane if you're curious. If it is false, your test point fails, you hop the line, you go to the other side of the line and you shade the other side. It's either one or the other. Okay. So if you see less than or equal to, less than, we're going to shade down. I'll show you that in just a second. If we have greater than or equal to, we're going to shade up the boundary line. Okay? So let's take a look at this example right here. What's it talking to us about? It's saying which coordinate pair is in the solution set of this right here. Okay, so do we need to solve for y? The answer is yes. So we're going to split this up just like we did in an equation. Remember, if you change sides, you change signs. So this minus 3x on the left becomes a positive 3x on the right. And I got minus 2. And, oh, look what I got here. I don't have y, I have a negative y. And there's a number right there. It's understood. You know what it is? That's right, it's a negative 1. Okay. All right, so if we look back up here, we're fixing to divide by the number in front of y. What's that number? It's a negative. So I'm going to divide by negative, so that means I'm going to flip my sign from less than to greater than. Negative divided by negative is a positive 1 in front of the y is just y, yay. Positive 3 divided by a negative 1 is a negative 3 in front of the x, and a negative divided by negative is a positive. All right, so let's look at what we got here. We have a greater than symbol. So we're going to use a dashed line. So I'm going to make myself a note. I'm going to dash my line. Okay? And then, if I look down over here, I have a greater than symbol now, so then I'm going to shade up. Let me show you how that works. Got a y-intercept of 2. Put a dot right there. And then we look up here, this is my rise and run. I'm going to go up 3 and left 1. Up 3 and left 1. Put a dot. Up 3, left 1. If I can't go up and left, I can go down and right. Down 3 and right 1. Down 3 and right 1. So this is where my line's going to go, but it's going to be dashed because I'm not equal to it. A dashed line is kind of like an electric fence. We can get close to it, but we don't want to touch it. Solutions are not on this line. So you can see I have two parts. I have this side up here, which is considered going up, because if I shade this side, I'm going to be going up on the y-axis. And over here, this is considered shading down, because if I shade this side, I'm heading in the downward direction on the y-axis. Okay? So if I want to shade this, I would just take my marker or something, and remember I'm shading up, because the y-axis is going up on this side. All right? So now I have this part over here. This is where all the solutions are. Solutions are here. Anywhere there is yellow shading, I can pick any ordered pair and it's going to make this guy true. Okay? So if I come over here and plot my points, I got 1, negative 1, 1, negative 1. This one is on the line. And because it's dashed, it's on a dashed line, it means that it is not a solution. Okay? Dashed lines do not contain solution. Again, it's an electric fence. Let's go to the next point. Negative 1, positive 1 is right there. Is it in my shaded part? No, it's not that one. 0, negative 1. 0 to the left, right. Negative 1 down. That's my y-intercept for this, or is this on the y-axis? Is this in the shaded area? No. Well, it better be this one, because we've eliminated the other ones. So let's go 1, 1. That's right here. This is in the shaded or in the highlighted region. It is a solution. There's my answer. Okay. Now, some people can do these problems. If they give you the line and the equation and just give you 4 points, they do it I've heard this called odd man out. So the single point that is by itself on one side of the line or on the line, if it's solid, is the solution. So we can kind of move around here and just say, well, let's plot these points first. 0, 6. Where is that? That's above the line. Okay, great. What about the next one? Negative 6, 3. That's also above. So those two guys are together. They're not the odd man out. About 2, 9. 2, 9 is also above. Well, these three guys are on above. This one, if this one is below, he's the odd man out. Negative 3, 1 is right there. He's the odd man out. Okay? And I know that's my answer. Now, you can solve this thing for y. Okay? If you notice, we're going to have to, if we do that, we're going to need to divide by negative. Change sides of the 5x becomes a negative 5x. And we're going to divide by negative 6. What's going to happen to my symbol? It's going to flip. Greater than shades above. So if we're shading above, these guys over here, these are solutions, which means that this guy, the odd man out, is not. Actually, this problem is miscopied. This is which ordered pair is not. Sorry about that. Okay, because these guys are. Let me finish the inequality. You can see I have a y-intercept of 5, and my slope is up 5, right 6. Okay, so these are the solutions up here. This guy is not. Odd man out. Okay, sorry about that. All right, let's go a little faster. All right, what is the inequality for this graph? I love these problems because it's just, we're going to take y equals mx plus b and we're going to morph it into something else. You ready? What's my y-intercept? It's right here. It's between 0 and 2. My y-intercept is a positive 1. I need the y. I need the x. What's my slope? Well, let's do a slope triangle. I go up 3 and I go right 2. Up is positive, right is positive. So my slope is 3 over 2. And my line is dashed. So a dashed line is either greater than or less than with no symbol underneath it. And am I shading above or below? is my line heading up on the y-axis or down on the y-axis? The shading is heading up on the y-axis. So we're going to pick greater than. And there's my inequality. All right, on this one right here, we can do odd man out again. This time, all we got to do is check the x's. So is negative 6, where's negative 6, 7? It's somewhere right here. Okay, this one is to the left of the line. This is 5, negative 6, which is also left of the line. And this is 4, positive 6. This is left. This one is 6, negative 7. This is on the solid line. As long as you're on a solid line, it's okay. So which ordered pair is in the solution set? Is the one that's greater. This is greater. Greater than goes this way. And you can see since the line is, this is the odd man out, that's the one we want. All right, and this last one, sometimes if you play the matching game, you notice over here, hey, I've got 2 dashed lines and 1 solid. So in this case, the only one that has a solid, this is solid, right? That's the only one. I'm going to just kind of sneak by that and say that one's the C because that gave it away. If not, I would have to solve for Y and make sure I could have the shaded side. Matter of fact, you might want to try that just to verify it. So it's one of these two. Let's just solve for Y. This one's going to be easiest to solve for Y because all I got to do is divide by 5. Well, dividing by 5 flip my symbol? No. All right, so they both have a y-intercept of -3. The question is, this one has a negative slope. They both have negative slope. So we can do the slope triangle. If I go, if I do a +4 over a -5, that means I would go up 4 and left 5. Let's see if that works. 1, 2, 3, 4. 1, 2, 3, 4, 5. I think this is the one we want. Okay. If we look over here at B, we've got 2y. Switch sides, you switch signs. Divide by 2 won't change it. And divide that, got the same y. So if I go up 3 and left 2, that's this one right here. So it verifies that this one's going to be B. Okay. Over here, we're shading up or down. Less than is down. Does that actually do that? Does it hit the shaded side? Yes, it does. On B, this one is also shading down. You can see that we're hitting the shaded section as well. And if we do this one, we're going to see that the shaded side is going to be greater than. It's going to be greater than because I'm going to divide by a negative. Matter of fact, I can do that really fast here just to show you. We divide by a -8. Symbol switch from less than to greater than. And we're done.